who will give us a talk on various exceptional sets in Manin's conjecture dimensions.
Well, I would like to thank the organizers for the invitation. And my first time to Edinburgh, and so let's start. So my topic is so there stands exceptional set in the conjecture in dimension 2. So attempt use projective rationing rationally connected variety over a number field, and that L be some big and left line bundle on X and with some additive matrix. So in this case, we can, so this induce a height function on the rational point on X. So then the Manin's conjecture so predicts that so
You pull the other board down.
Yeah.
So yes, the conjecture predicts that. So suppose XF is not a thin set, so which will define it. So then there exists a thin subset in X such that so the counting function of rational points outside this Z with bounded height. So the growth rate of this counting function should be C times B to the power A times log B to the power B minus 1. So where A and B are birational invariants associated to the X and L. And C is the Peirce constant, which is related to the number of rational points over finite fields. So, okay, so remark. So in the original version, so Z was assumed to be proper closed in matrix Manin. 90. So then there was counter examples. Found by Matrix and Chinpyo in dimension at least 3. So then there's a so the thin set version. Here, so suggested by here. So then there is a canonical choice of Z, which we call ZLST of Z. So proposed by Manin and Gupta Tanimoto. So so the basic idea is to to include contribution from rational points from direct finite covers of X from with higher A and B invariant. So the goal of my study is to classify surface X with dense second set proposed by XC. So previously there was no example in the main. So by a kind of MMP, so it reduced to study polarized pi pair X minus KX where X with the photo surface. And now the S from Y to X is some generic finite cover with large A and B invariant. So then we can consider the Itaka dimension of this boundary divisor. So I have to mention that in this case, when X is a weak dipole surface and polarization is minus K, so A is 1. B is Picard rank of X. And there are two main possibilities. So this boundary divisor, the Itaka dimension can be 1 or 2. So if it is 1, then this you use to study rational curves. Family of rational curves on X. And this to the so by further MMP, so reduced to quasi-Etel cover of well uniform surface. So where quasi-Etel cover means so then I state my mean theorem. So in my first paper, so I find smooth Diopolo surface of degree 1. With Picard rank 1 with dense exception set. So I should mention, so whenever we find such X with Z with dense Z as so we can use Brownian log form to prove that so these examples are counterexample to the original version of Manin's conjecture, to the proper closed version. So this example it comes from a family of rational curves parameterized by an elliptic curve. So on this X, so which are conic, conics on this X, but not from conic bundles, because so if there's conic bundle structure, then the pK rank will be 2. So and we want the pK rank to be 1. And in this case, so this cover becomes so with the same A and B invariant to X. So so by running local, so this should be included in the server set. So so in fact this rational curves comes from linear system. So the rational curve in linear system of minus 2kx. So when x is a dual power of degree 1, so the minus 2kx. So it's a double power to P112, which is a P3. And so a hyperplane. So let B is a branch divisor, then the branch divisor is of degree 6 and minus 4. So whenever a hyperplane so go back to a rational curve in this linear system, so that hyperplane should be a bitangent plane. So okay, so the converse. So when it is a bitangent plane to the B, so it pull back to a rational curve. So we find a special X such that there exists a linear involution of B, and this induces a bitangent plane. If this happens, then by Hurwitz's formula, you can compute the genius of the quotient of B by this evolution will be 1. So, and of course, there are many other so technical parts. For example, you need to find a rational section of this. So to make sure the conics are conics but not Bravo-Severick curves. And also, you need to make sure there are infinite many rational points on this E. And in this case, you'll find a dense set of rational points on X, which should be included in the external set. So,
a quick question. What's the ground field here?
oh, yes. So in my example, the ground field is Q.
Okay. And so then, if I understand correctly, you're saying that we
no. So in my example, so it should be some number field.
Okay. Any number field or some particular number field?
Particular number field.
Okay. Okay.
You are joined root minus 3 or something.
Root minus yes. So so I didn't find an example over Q, but so only over number field.
So then, I think if I understand what you're saying that if for Manin's conjecture to possibly hold over this particular ground field, we would need certainly to remove this dense set.
Yes.
Okay, good. Just
Then so let's move to the second part. So when the Itaka dimension is 0, so we will study quadratic cover of the logic subscript. So let pi from T to S be such a quadratic cover. So we want to find such quadratic cover such that the Picard rank of the minimal resolution has a relation that so for T is greater or equal than for S. So in such case, we have to remove the contribution of reference points. So okay, so how to study this? So for example, we use a root system is one-to-one correspondence to the type of dual surface. So also almost one-to-one because some cases are not exist in characteristic theory. So and then my first observation is that so let's fix notation as before. So let's for example let X be a minimal resolution of S, which is a weak dual surface. So in this case, so the smooth part, the fundamental group of the smooth part of S is isomorphic to the Picard lattice quotient is -2, the sublattice generated by -2 curves, and take quotients. So it's easy to observe that these are equal when this fundamental group is a abelianized fundamental group. But you can further observe that so when S is a dual to the power surface, so and you have a quasi-Etel cover, so a general member in -k is an elliptic curve. So whenever you have such a cover, you get a Etel cover of a elliptic curve. So which must be abelian.
Sorry, what is x goes to x? What is rho x to s?
So yes, I should. This is minimal resolution. Of singularity. Is that clear? So yes, because S is a dual dependency, so we have a one-to-one correspondence between dual and weak dependency. So and then so in this case, you only have a rational map from Y to X, where Y is also the minimal resolution, so of T. So so my second thing is that so if you take the normalization of X in the function field of T, not by F. So there will be a rational map to Y. And I claim that so G is a morphism. And the exceptional divisor of G is equals to the ramification divisor of F. So because they have a canonical singularity, so we can prove this. So by this we can so first of all from this computation we get the branch so the possible branch divisor of this cover, and then we take the branch cover, and then from this result we know we should contract which negative curves. So then we get correspondence between so negative curves on Y and X. So we get somehow a correspondence between the negative curves on Y and on X. So here this should be means so not only the negative curves but the curve which generates the extremal ray in the of the pseudo-effective cone. So then we can compute. So let's define the so hormonal isometry of X. to be the automorphism of the pseudo-effective cone, which preserve the intersection number and preserve the minus kx. And so whenever two wave Gao surface there exists such a hormonal isometry, we say they have the same type. So this is the definition of type. And I can so we observe that so the Gauss group. So whenever you work over non-closed field, the Gauss group will act on the Picard group of the of X and Y, and this action factors through some new group. We call it hormonal isometry of pi, so which is defined to be a subgroup of that of X times that of Y, such that which is equivalent to the this correspondence. So then so this X on the Picard group of X and of Y. So by this data, we can determine so all the possible actions on the X and Y, and together all the possible Picard rank for this cover. So yes, okay. So I don't have too much time. Let's take an example. So so yes, I forgot to say my main theorem. So there exists with your puzzle of degree 1, 2, and 3 with dense exceptional set. So let's talk about the unique example in of degree 3. So which is a Haley cubic surface. So this notation means degree 3 Gao puzzle with 4 A1 similarity. And there is a partly detailed double cover from smooth DP6.
Question.
So are these all over Q?
Oh, you mean which part?
So what is the field?
Oh, here. So I realized, so first of all, so that computation is just over C. So I just compute the group actions, and I found explicit examples over Q, in fact. So realize such a so the example I found are all over Q.
I wanna give a equation for cubic.
Oh, for cubic? Oh, okay, maybe I can, maybe I have some time to give. So, okay, so let's talk about this. So in this example, you have many choice of the group action. So for example, when Y is split Gao puzzle of degree 6, then the Picard rank should be 4. And so of course, so this moves, so this is also true. And so you can compute the, so because S is the quotient of T by some G, where G is a on the, so this is a 6 -1 curve of PP6. So this G interchange the diagonal the diagonal curves. So this is C. So and S is isomorphic to the, so this quotient. And so this is equals to the equivalent Picard rank of this on P, and so you can compute directly that. So this equivalent Picard rank is so in this case it's 3. So rho S is 3. And in this example, so you can have a Galois action which is a C22 on the S. So in fact, so on the 4 singularities, so which makes one orbit. So you can blow up this orbit to get X. So X is of Picard rank 4. So they have the same Picard rank and should be included in the set. So to get the equation of such action is also elementary. So observe that so the Cayley cubic is given by a symmetric polynomial, and you can take any number field over Q with roots A, B, C, D, and with Galois group isomorphic to to what you want. So pick such a number field. So let A1 to A4 be the root. So then you can take a coordinate change of X. So by the Vandermonde matrix. So frequent AI J is a 4 times 4 matrix. Then so the original F is given by so this is the definition of the polynomial of Cayley cubic, and you take A inverse X, the coordinate change, and you get so because all the polynomials are symmetric, so this all the coefficients are symmetric polynomial in the roots, so they must define over Q. So we get a desired Galois action. So and finally, so I want to mention conjecture of Collier-Taylor. So when X is rational connected, then the closure of the set of rational points in the Brown-Manin set. So it's so the analytic points equals to the Brown-Manin set. So and this implies rational points on X is not a sin set. So which is crucial. So in some sense, Manin's conjecture assumes this conjecture because so to exclude sin exception set, so you want the original set is not sin. And secondly, so in the definition of Pierce constant, so this Brown-Manin set was used. So by a recent result of Achwald Wittenberg, so whenever you have such a quasi-detailed cover of the puzzle, of Duval surface. So if this conjecture known for all twist of T in some sense. So then it is known for S. Or which is called super descent. By my computation, I can prove so Collet-Tennant's conjecture for many low degree Diopazzo weak Diopazzo surface, so which might be new. So so there is a DP4 covered to degree 2 with 4 A1 singularity and 20 lines, and to degree 1 with 6 A1 singularity. So which is C22 color. So I can find explicit example of such cover such that so these two have theta rank 2 over the base field. Then by a classical result of Iskovsky, so they are minimal. They are minimal conic bundle. So this and because so the Collet-Tennant's conjecture is known for DP4. So by Swinnerton Dyer. So we conclude that so the conjecture is known for such conic bundles. And so yes. So and in this case, there so these two surfaces are not rational. So this is crucial because if it is rational, then so the conjecture is automatically known. So this is meaningless. So we have many other similar examples. Such as so in degree 1 with 4A2 singularity, 2A4 singularity, 2D4 singularity. So I'm not sure if this is meaningful, but so whenever you have a weak Diopazzo with such so dual Diopazzo with such singularities, then the conjecture should be known. Okay, I'll end it.